And now we'd like to start a sort of panel discussion with the invited speakers, but also possibly with all the participants to the workshop. So I would like to invite all the speakers that are still connected to turn on their cameras, and the participants yet to switch to speaker view. So I'm going to start with an initial question, but as I said, I'd like to invite all the participants to join the discussion and to ask their questions. You can post them as usually in the chat, or you can also raise your hand to interact directly with the speakers and with the others. Just to raise your hands. If you don't know how to do that, in the reaction button, you have the option to raise your hand indeed. And so I will start. So I will open this discussion, and together with the organizers, we were thinking, I mean, we organized the workshop across three main topics, which are design, learning, and control for safe human-robot collaboration, which gave the name to the workshop. And we were wondering what is your opinion about what of these three areas is the one that deserves the most attention, either because we can say it is not mature enough or less mature than the others, or because it shows the greatest potential. So which among design, learning, and control indeed, or maybe not a single field or a synergy of these fields. So I don't know who wants to start, or I don't have an order. So
maybe Alessandro, that is the freshest of all of us.
Sure. So I think that one of the things that I like about robotics is that it's a system science, and one of the things that I like about this is that there's no winning solution to most of the problems that robotics faces, right? So I obviously I'm coming from the perspective of trying to look at improved robot capabilities through novel designs and novel hardware, and trying to look at the full system. But I think that to solve the problems that we are going to be facing in the new generation of collaborative robotics, we should be looking at all of these components together. And human interactor, human factors, ergonomics, and all of these things are part of that. But obviously, without interesting capabilities, robots are useless. And so I think that the importance of each of these fields and putting them together is, in my opinion, relevant. I can just pass it to Sylvain.
Yeah, maybe I would like to add that the other advantage of taking the three all together is that you simplify each part in some way, in the sense that if you focus only on a single aspect and you freeze the two others, it means you need something quite complicated in order to make it work. While if you treat the three all together, you can actually have solutions that are maybe simpler for the three aspects. So of course we will all have like one specialty, so it's difficult to find like the good amount of expertise to be able to tackle the three all together. But at least I think it's important to consider this, that if we look at it from a global perspective, we also have the chance to make each of these systems potentially simpler.
See, maybe Andrea can say something. I'll go in like in order, alphabetical order on the chat, on the participant lists.
For what is the concern of my research, I'm kind of just saying I'm kind of surprised looking. As you know, what I've been talking about was industrial robotics and manipulators in particular. But if I look at autonomous vehicles and cars, there's a tremendous hype on deep learning and learning in general that I don't think would be relevant in the field of industrial robotics. There are strict regulations where if you put deep learning, nothing is going to use your tool in industry because you cannot certify that. And then nobody is going to even consider using deep learning for safety, for example. So I think, yeah, learning is kind of important, but when it's about to talk about safety, yeah, you have to have control under what you're doing. But still, I understand that learning has a potential to be on top of safety, because what the robot can decide to do or not to do will eventually influence the safety of the task. So it can decide to do something because in that specific instant, it's more convenient because doing this instead of that will stop the robot a less number of times. So it can be more productive because of safety. So I think that has to be on top of learning, has to be on top of safety, not in parallel, which is actually what's going on within autonomous cars. So I do strongly believe that this is the way, at least for my interest in industrial manipulators.
Maybe I can give my opinion. For me, safety and also general human-robot collaboration or any kind, even autonomous robot behavior, I think the bottleneck is still, I would say, artificial intelligence, which would probably go under learning. Because I always give this example. So even with the current low-level controllers and hardware, if you are teleoperating the robot, you can do 1,000 times more than what just the robot can do. Like in terms of cognitive complexity and all the tasks that you can do with the same hardware, with the same low-level controller, just different brain, let's say.
Sounds good. Yeah, let's hear also what Federica has to say.
Yes, I agree with Andrea that in industrial application, the control problem is a very big problem, and learning is quite difficult to be applied. However, I think that we should focus not only on safety, but even on performance, because we are always thinking about how to guarantee the safety and so on. But if we overbind in this sense and we try to satisfy everything on the safety point of view, then the performance would be not enough for sure. And the trade-off is something that I think all of us are studying, but it's not so easy to be obtained. And so I think that going into this direction from an industrial point of view would be really nice.
Yeah, I think everyone has given his opinion about it. Maybe we can go on with the last things we heard, because indeed, so safety is really important, but performance too. But do you think it's possible to change the regulations that we have now in industry? Because the regulations that there are now around safety are really strong, really hard, and they really suppress the performance of the robot. So do you think that these regulations can be changed if we can show as researchers that robots can be safe and still have a high performance? So yeah, maybe that's a question also that Federica or Andrea can answer as the first ones.
Well, I think that the regulation should be adapted, because I think that they are still too much conservative at least the technical specifications. We are trying to work while satisfying the values given by the standards, but they are very, very conservative. And even the model that is inserted into the specification is something that should be improved to be really useful in the industrial field. So I think that an adaptation, because the technical specification came in a moment when nothing was clear, and no standards were present for collaborative robots. And so as a starting point, it was very nice, but now I think that it should be improved and should be made less conservative at all.
Maybe Andrea can also.
Yeah, I'm not of the same opinion, but I think they're not conservative. I mean, if you look at the speed and separation monitor, it's just saying that you have to stop before colliding. The power force limiting threshold, so the data you see in the table might be conservative. But if we look at how those specifications, how those criteria are actually implemented, they are implemented in a way more conservative way than how they are specified. So if you take an industrial robot, the safety control, it doesn't even know where the robot is. The robot is just a cylinder, and the robot can be anywhere in that cylinder. And then you say, okay, that is the row space of the robot. Then you enlarge it and you say, okay, when something enters this enlarged workspace, you have to stop the robot. That is speed and separation monitoring, but it's way more conservative than how it has been specified within ISO 15066 or whatever, 10218. So they are implemented as way more conservative. And the reason is that we probably have bad sensors or bad control architectures within industrial controllers, because the safety regulations are actually allowing to perform better than this. But probably either we don't have sensors or we don't have a sufficient way to integrate different algorithms within the industrial controllers. On the other side, you still have to do some risk assessment, which means that you always take something that is reasonably acceptable for the residual risk. And which means that typically, if you do that, so you're over constraining the system to be more safe than required, then sometimes you basically you're actually achieving a performance level that's higher than the minimum that can guarantee safety up to a certain level of risks. I do think that there is a huge gap between what we can do as researchers and what we can eventually implement within a controller, and the industrial cabinet. But I don't think that the regulations are actually too much restrictive if we talk about speed and separation. I would really love to see something that is less restrictive for the power and force limiting as well, because if you have a really power and force limiting robot, that's probably going basically at very low speed all the time. That's why typically they use a laser scanner just to understand whether human is in, and when it is not, it's just going at maximum speed, like in speed and separation. My only concern is not really regarding safety and regulations. My only concern to see actual implementation of collaborative workstations, as I don't see really relevant examples in industry so far.
Yeah.
I don't know. Can I continue on that?
Yeah, of
so
course.
I think we shouldn't blame the regulations and so on. I think to be completely honest, collaborative robotics was overhyped for what it is. It's really a niche. If you go to industry, maybe there's 5% of tasks where collaborative robotics can be applied. And yeah, talking to industry and to robot producers who actually sell and distribute, my experience is that many times, because it was hyped, the companies bought it, but they just didn't have the task for collaborative robots. So yeah, maybe we should just step back and see what's in reality.
Yeah, that's also what I heard, that companies bought those collaborative robots as cheap industrial robots, and so they don't use them really in collaboration with humans. But what do you think then that would be a good task that a collaborative robot could do in the industry?
Yeah, a very difficult question, actually. I walk through companies like just to see myself where I could, and it's quite difficult to find. So for example, I have this example of polishing, but today it's better to do autonomous polishing. It will be faster. So when you buy a collaborative robot, you also have come with this trade-offs, but it's less precise, it's slower, it's more expensive. So in the end, I think most of the tasks in industry either, they're mostly for one agent tasks. Very few are multi-agent that really needs multi-agent, especially for the physical human-robot collaboration.
Yeah.
Maybe to follow up on this. Oh, please.
No, please.
No, I was just maybe like taking a step forward, saying, imagine not the usual robotic manipulator, but rather the mobile robots or ground or even aerial, right, that are currently being used also for constructions. Like in that case, I think for sure safety regulations will need to change, or even there is a larger gap, right, in what we can do and what the safety regulation will tell us to do. Maybe in there is a lot more potential. And even in a heterogeneous multi-robot systems of these, right, there could be a lot of potential. That was like my comment.
Yeah. So the only thing that I wanted to add is that I totally agree that Uber collaboration was overhyped and they never delivered on the promise. But I think that, in my opinion, is a combination of factors. The first one is that in industrial robotics, you can still afford to completely structure your environment around the robot. So all of the good, nice things that a collaborative robot has are completely useless, because you can, again, coming back to what Sylvain said initially, most of what we do is to try to simplify everything in order to have very simple solutions to complex problems, right? So, and the simplest solution in industrial robotics is usually spending less money and having it more structured so that the robot does what it is supposed to do, right? And I think that, and again, I talked to a lot of companies and startups and all these things. I think that the true value of collaborative robotics is not in industrial applications, but is anything that is not industrial applications. So Gennaro was talking about a number of different domains like constructions, or anything that has a lot of clutter, noise, there's no structure, you cannot predict where objects are. And my favorite is human populated environments. And that's why I was looking at this idea of professional kitchen. But there are so many different domains in which you cannot have an industrial robot. But for sure, I don't believe in the idea of having a collaborative robot in industrial applications. We should try to move toward where it is, where does the separation between industrial robotics and stuff that industrial robots cannot do, and focus on these type of domains. And there's a lot of applications, right? It's just that collaborative robots they don't have any value in industrial robotics, in my opinion. Just very frankly speaking.
Very strong sentence. Anyone wants to follow up on this?
No, I just want to add that, yeah, I was talking about manufacturing. So of course, other fields like construction, retail, even agriculture might have more.
Yeah,
Exactly.
I do not completely agree with Alessandro. Yeah, just to say it clear, I see two things. One is collaboration, the actual collaboration, so doing things together, and within that I agree. And then I see collaborative robots, so the thing that you buy off the shelf, which is a new generation of robots which are not just safe to work with in some sense that we have discussed today, but they are also easy to be programmed, reprogrammed, relocated. And that is somehow connected to the idea of Industry 4.0, as Bram introduced today, so mass customization. If you really want to be flexible in changing from producing product A to product B, you don't want to reallocate all the agents you have, then basically it's just 4 screws that you have to unscrew and relocate with robot, and you can reprogram the robot in a while. So in this sense, I would say a huge potential of this kind of, let's say, new generation of robots, but even caged. Still cage you cannot relocate, but you take the advantage of having a robot that can be mounted in some manner in a cage-free environment, and you can change the location, you can change the program, so to produce something different. And the way I would change the norms and the regulations in order to further boost this this trend would be to ease the risk assessment that is more general towards a flexible implementation of robotics. Because in principle, in every time you change substantially or not your application, you have to reevaluate the risk assessment to see that you're still complying with what you said the application before. And the way I would change the regulations is with retrospect. Then I would completely agree that as of now, we are not taking all the potentials of this machine to work with people, with humans in structured environments, and probably they even need this kind of collaboration, but they are easy to be used. Still, on the other hand, there's this problem of redoing the risk assessment if you want to use it in a different manner.
Yeah, I would also add to this that also, yeah, this store control capacity enables better in physical interaction performance. Even if the robot does something on its own, it's still much better than the industrial.
Yeah, in some way there are several forms of collaboration, like maybe there is a weaker part of collaboration where the task is still the robot doing, like we still target a task that the robot will do on its own, but the way we program it is introducing this collaboration component, as Andrea was saying, and I think it's something that we should also keep in mind. And maybe the stronger form of collaboration would be that the task is requiring the robot to collaborate with the user.
You spent a lot of time in learning by demonstration. That is only feasible with one of the 4 possibilities for collaborative applications. So manual guidance is one of those 4. Even power and force limiting is something that is protecting the human safety whilst you are demonstrating a task physically on this kind of robot. That is impossible with an industrial robot. And so in this sense, I would completely say that what we are doing is still relevant, but not probably working side by side. Still, a demonstration of a new task is a collaborative application to me.
Maybe a question that was asked during the workshop that was answered by, that is related to learning, that was answered already by Bram Abhinav, who unfortunately cannot be here at the panel. and Luca. But I think Sylvain was not there yet. So the question was, in your opinion, what is the major challenge or difference between learning for autonomous application and learning for human collaborative tasks? Because I guess in the human robot collaboration, learning can really help in the human related side, right? Rather than in a task that is fully autonomous. So Sylvain, can you comment on this?
Yeah, like even the design, I would say, even the design of the way we provide the demonstrations also need to change in this case, because often we need to put either to have varied exposure of situations so that we know how to react by having like different inputs. So it's obviously more challenging to have demonstrations that are targeting a robot collaborating with the user. But I guess it's also in these applications where we need to think about the representations and also think about making several systems work all together, because it's here that you very likely need to have a strong control component and to really think about what the learning component is doing. So thinking about the probably to have, like, I would argue that we will need to have some behavior primitives, and that the learning component would be only to orchestrate these behavior primitives. And each behavior primitive could potentially be something that where we can have like a safety guarantee. And if we have the learning component only orchestrating the sequence of these different components, and possibly to put several of these components in parallel when the safety can still be guaranteed, here I think it's a use case where learning can still be used without having a safety issue.
I agree. I think maybe Andrea, who was not there yet, can comment on this.
Yeah, I was there this morning, but I completely agree. Sorry. Yeah.
Okay.
So can I turn this into a question? And this is primarily for Andrea. So do you think that we cannot have any future standards that are going to be incorporating learning in safety? Like, how can we make that happen? Or do you think it is not possible?
Yeah, as of now, it's not possible. I mean, you have to characterize to which extent you can trust your algorithm. And if you look at the recent documents from the European community, safety in industrial robotics is one of the field that is a critical application of using AI and so learning. If you look at that document, it's basically say that you have to prove a priori the characteristic of your system, which is making no sense to me. But somehow I read on these lines that we cannot use it for safety. And the reason is that how can you guarantee the performance or the characteristics of a learning system a priori? So before selling your product, whilst your product is aimed at learn from future experience. And that is one problem that I think it's written there in the European regulations document and for future regulations document. And then the other problem is that safety critical applications is defined to be even more restrictive in the use of AIs. So if you look at that document, to me, the future is if we decide to follow that document, is there's no space for using AIs in safety critical applications. And that was kind of surprising me, because if we look at your side in US, there are a lot of hype in using learning systems for autonomous vehicles, which are to me a safety critical application as well. So, but when it comes to go into factories or the use of robots, even outside factories, so for service professional robotics, there's no way to use this. Deep learning and convolutional neural networks or object detection using deep learning, that it's not possible.
Yeah, but in the end, I mean, humans are also black box systems, and they let us work and they trust us. So my argument would be, if the AI would be on a higher level than it is, maybe then they would start trusting it as well, even without having the ability to see inside, because we also have a lot of machine learning. For example, what Sylvain is using, what I'm using, is not black box. So, but still probably it falls under the same category, that they don't trust it, just because it's on the level that it's not what it's supposed to be.
Yeah, maybe one first step towards safety guarantee would be to look at interpretability. So to see if we could have interpretable models that could be privileged maybe over models where we could not really know exactly what is happening, or even by post-processing what happened, we cannot really redo it. While if you have interpretable model, it's maybe offering an opportunity to go toward this direction.
Maybe we should also rethink the collaboration, because we're a little bit biased. I mean, when we talk about collaborative robots or human-robot collaboration, we always think about industry, right? But there are other forms of collaboration or close by. Like, imagine when we work in outside factories in, let's say, disaster environment or underwater, and we use a robot in teleoperation, for example. And robot has some autonomy or some, now I'm biased by my research, but so when you use a robot in shared control, for example, this is a form of collaboration. And there, I think there is a lot of room for improvements or for using all the algorithms regarding safety or learning and things like that. So I think we should also focus our research, our attention towards these kind of applications of collaborative robots. What do you think?
Yeah, I think maybe teleoperation is one thing that we kind of skip out, but I think it's a very good example of collaboration, even though it's more on the control level than on the physical level. But I think it has a huge potential.
Yeah, because I was linking to what you said at the beginning, right? I mean, with the human brain in the loop, robots can do very, very cool things.
Yeah.
So, and that's a form of collaboration to me.
Yeah, it is.
Yeah, it is. And then I've been working a little bit on teleoperation as well for pharmaceutical manufacturing company. That's basically you completely avoid the safety problem, because they in one part of there is a human and a robot is teleoperated, so it's remotely operated, and that there are a lot of pros in implementing in industries even or in hospitals this teleoperation. Because you completely remove the human from the source of danger, which is not the robot anymore, but it's the chemical environment that you are operating in. And I see some delay, but I see the same trend of industry also in the medical and the healthcare system, which is mass customization. As in industry, also the medical treatments are going to be more and more customized towards the patient, not the customer anymore, but the patient. And you can do this customization without the humans. But if you want to customize the treatment, the medicine, the drug, whatever, and you have a lot of patients probably because of the aging society, because of the pandemic, you probably need some automation at least. And you can't really automate 100% every task that is currently done manually. And so you can rely on teleoperation. For example, if you have some chemical or hazard or biohazard zone, or you can use some kind of programming by demonstration or teleoperation with programming by demonstration to train the robot how to solve new tasks, or how to produce a new drug that is patient specific, for example. And there is a lot of potential there as well, I think.
Yeah, just to conclude, I mean, we can think of using the methods that we have developed so far for industry, like low-level safety controllers or high-level learning systems, in this case, to provide assistance, like to the humans using those robots, for example. So we have not wasted our time, like developing these methods.
Yeah, but I wouldn't say we are wasting our time. I'm saying that industry is very slow in implementing and changing paradigms. So eventually, in 10 years from now, there probably some new regulations will come up, and of course, those regulations are oftenly revised, but they are changing a very small amount of parts. With a very low frequency, but that's something changing actually. So the fact that from 2016 until now, so in the last 5 years, we can tolerate contact with non-zero speeds between a robot and a human is something actually new. So it couldn't exist before. And now we are there since the last 5 years. Something is going to change probably in the future. But you see that velocity is very low. So it's nice to push something as well, but we cannot pretend that whatever we do is going to be implemented or is going to be evaluated as state of the art from the certification perspective.
Yeah, I agree.
Maybe since you are almost out of time for the final discussion, I hate to close. Maybe to end on a positive note, can any of you think of what is the biggest challenge, right, on the safe human-robot collaboration we as a community you think we should work on? Or equivalently, pretend you are a first-year PhD student starting now in the human-robot collaboration field, right? What is the work or the topic you would pick and work on for the next 4 or 5 years? Let's start on the participant list with Alessandro.
There is actually a question in chat.
Oh, very nice. Maybe let's pick that.
Maybe we should start with that
before. Yeah. So, all right. So the focus has been on the robot aspect in human-robot collaborations. What would the new key role of human to play for future? Can human be used to address the regulator's concern in using AI for human-robot applications? From Erfu Yang.
Yeah, maybe I can start answering that. And I think that the importance of the human in both industrial robotics and beyond is not going to disappear, right? The difference is that the role of the human in industrial applications is going to be different. Possibly the human is going to have more throughput, or is going to be operating multiple robots or interacting with multiple robots. And this is going to be hopefully ultimately beneficial to the human, right? But the idea is that with an improvement of technology of autonomy, perception control, and so on and so forth, we are basically going from the traditional industrial robotics paradigm in which robots are replacing people to a hybrid paradigm that we're using right now, in which humans are actually helping robots. So you can look at teleoperation, you can look at learning from demonstration. You're using some higher level cognitive capability of the human in order to achieve some something with the robot, right? You're using the robot as a tool to perform a task, but the cognitive load is on the human, right? And then ideally, hopefully in the next 10 to 20 years, we're going to be having realistic applications of robots helping people. And obviously there's a lot of research about it, not much, as we said earlier, in realistically in commercial applications, but this is the direction, right? So the role of the human is a role that is shifting and is going to be continuing to shift because the role of the robot is going to be increasingly more autonomous, in my opinion.
Yeah, if I was a PhD student, I would start my topic on robot-robot collaboration. So I think even if the robots were smart enough to be able to seamlessly collaborate where the collaboration is needed, I think why not just use robots in the factories? So and then let the humans do some more nicer jobs. So I think maybe this might even be the future. So I mean, like it was said already, so all the effort now wasn't wasted because all this effort that we made will be useful maybe for robot-robot collaboration as well, and for other parts of it. And humans still will have to be some kind of manager and supervisor and maintainer and repair and relearn when needed and so on. So there's still a lot of opportunities.
Yeah, I like this clear answer. Sylvain, can you?
Yeah, maybe another opportunity is to study user preferences, in the sense that here we often we are developing something that the user will have to use, but we not necessarily providing so much flexibility to the user. While ideally we would like that there is a tool and the tool can be used in different ways, in the same way as I can collaborate in different ways with someone. Like with someone else, like I can have like a very rich way of collaborating. So it would be ideal if we could also have this flexibility with our robots and to study from very low amount of collaboration to high amount of collaboration along different, let's say, axes of collaboration, and to let the user decide what form of collaboration he or she would like to use, and also how it's evolving with time, because maybe you start with one form of collaboration, but when you get used to the system, later on you use a different forms of collaboration. A bit in the same way as with computer interfaces, maybe we can switch from one graphical user interface to a terminal user interface, and it's not really fixed in time. This might evolve with your knowledge on the system. So here, I guess, one of the further challenge would be also to consider this when we are developing human-robot collaborative systems.
Maybe Federica and Andrea can.
Yes, I would work on something that Mario anticipated before, which is the combination between two kinds of controller: an high-level AI controller with all the learning problematics and so on, and the low-level safety controller with more formal frameworks for guaranteeing the safety. And this is what Andrea discussed a lot even in our talks. And how to combine these two kinds of controller, I think that is a good challenge for the future, because we can have the AI controller, we can have the safety controller, but they have to talk in somehow, and they have to work together to obtain the best performance. So this is something that I found really interesting, and I was completely agreeing with Mario when introduced this point.
Yeah, if I can complement, I would study the problem of still assuming mass customization. I would study the problem of selecting the best policy for a robot. That's I'm talking about learning part, so that problems regarding safety are going to be minimized. So when you're going to run this policy, that could be a discrete policy saying do task A or task B. I would like to learn the implication of this decision on slowing down the robot, for example, because of safety. And that would ultimately, based on current specifications, current implementations of safety, but I would learn a policy that will allow the robot to be not to be interrupted too much because of safety. Now it's something I would study. But then also, I would like to say something regarding this human versus robot. I don't see any actual risk of being substituted completely anytime soon. So I have seen a lot of companies, from small to big companies, in the region around here, where we can think about having a lot of robots, but there are practical limitations, and you will see humans there for many years from now. And then that's typically the assembly application. So you see, I mean, factories are 99% human driven. Of course, if you look at cars manufacturing, that is 50% robots and 50 humans probably. But if you look at washing machines, apart from the press that's shaping the washing machine, everything else is human. And there are a lot of humans, and still we have difficulties in implementing robots there, because they are asking robots to do tasks that are not able to do yet. And this is something that is really incredible when you read the press news saying, okay, robots are going to substitute all the humans in factories in 2 days. And I'm kind of surprised reading this, because we are struggling in the labs doing something that a human can do, and probably we can run the demonstration once or two, but without actually the robustness of the same task performed by a human. So we do once we publish a paper, right? But in companies, that's just not enough. So they want to run the same thing 100,000 times without any error. Robots are not able to do so in such a robust manner. And it's not going to be anytime soon like that. And I do say that it's impractical to think about robots substituting humans everywhere. But still, I see some possibility of having this collaboration, but I don't really understand why it is not yet used.
All right, yeah, and on that positive note, I think we can close the panel discussion.